Welcome to clickmyproject.com. Now we discuss about the title Robust Retinal Vessel Segmentation via Locally Adaptive Derivatives Frames in Orientation Scores. Now we discuss the abstract for the process. This paper presented a robust and fully automated field-based approach for retinal vessel segmentation. We propose a new filters based on the 2D frames in orientation source which we functions in the live group domain of positions and the orientations. By means of the wavelet type transform, 2D image is lifting to the 3D score. In the filter domain, R1 and S1 vessels are enhanced by means of the multiscale second order Gaussian derivatives, popularly to the line structures. More precisely, we have lifted the invariant rotation derivatives, that is the LID frame, locally adaptive derivatives, that is the LAD frame. The LAD is adaptive to the local line structures and it is found to the analysis of the left invariant Hessian matrix, that is the computer aided LID. After the multiscaling filtering via the LID and the LAD domain, the results are projection in a 2D plane and the enhanced vessel regions are segmented by use of the morphological. Now the blood vessel segmentation of retinal images plays an important role of the diagnosis and disease. So in this paper, we have to segment the blood vessels present in the retinal regions. So we have to use the morphological segmentation method and by the green channel intensity and the vessel enhanced image features by the morphological operations. However, the retinal images have low contrast and large visibility is present in the image acquisition process. So we have to enhance and then segmentation. Now we are going to discuss about the overall flow diagram for the process. This is the overall working flow for this process. At first, the input image is taken from the dataset. The dataset is nothing but the folder which consists of the several input image. Here we have the dataset images of retinal images. After getting the input image from the dataset folder, the pre-processing step is carried down. Pre-processing is the step which consists of 4 stages. The first one is the image resize. Image resize is the process to resize the image into an aspect ratios. After the image resize, the double conversion is carried out. In the double conversion, the data type of the image is converted into the double. Then the lab image is created. This is known as the lab image conversion. Then the optimization also carried in the pre-processing step. In the optimization, we have the enhanced image. After the optimization, the enhanced image is carried from the optimization. After the enhancement, the image segmentation will be carried down. In the image segmentation, we have to consider the 4 steps, that is the step 1, step 2, step 3 and as well as the step 4. In the step 1, we have to introduce an image and then in these 4 stages, we have to done the morphological image segmentation method to segment the retinal region from the other background region. The vessel region only extracted by these 4 steps and the other remaining regions will be eliminated. After the segmentation, the estimation part will be carried on. This is the final justification to improve the process is well efficient or not. In the estimation part, we have to estimate the 8 parameters. The first one is the accuracy, then second one is the sensitivity, then the error rate of the process, then the Jacob coefficient, then kappa coefficient, then dice coefficient, and also the true positive and true negative for the segmentation result. Now we discuss the initial running procedure for the process. At first, open the MATLAB 2013 and change the current directory. Now you can see the main_GUI.yam file. If you want to execute the code, just right click in that file and select the option run. Now the initial GUI design was opened. In that you can see the several push buttons and the two axes for the display purpose. Now just click the button input image. After clicking the button input image, the dataset folder is available in the path. You can just click the dataset folder and select any one image from the dataset folder. After selecting the input image from the dataset folder, the input image which we have selected is shown in the axis 1 with the title input image. Then click the button pre-processing. Now the pre-processing window was opened. In that you can see the 4 options. The first option is the image resize. After clicking the button image resize, the resized image is shown in the axis 1 with the title resized image. Now click the button image to double conversion. The double image is shown in the axis 1. Now the lab conversion will be taken when clicking the button lab conversion. The lab image is shown in the axis 1 with the title lab image. Now the optimization will be carried out. In the optimization result, the grayscale conversion is carried out. Then go to the main window and click the button vessel enhancement. Now the vessel regions present in the retinal image is enhanced. Now click the button vessel segmentation. Now the segmentation window was opened. In that you can see the 4 steps: step 1, step 2, step 3 and step 4. These 4 steps consist of the morphologicals. Now click the step 1. Now the segmented image, that is the blurred image, is shown in the axis 1. Now click the button step 2. Now the step 2 image is shown in the axis 2. Now click the button step 3. Now the veins regions are only extracted. Then click the button step 4. Now the veins regions only extracted from the image and the other backgrounds will be eliminated. Now click the button estimations. After clicking the button estimations, the estimation window was opened. Now load the ground truth. Ground truth is nothing but the image which consists of the previous segmentation results. Now click the button accuracy, checker coefficients, error rate, sensitivity, then kappa coefficient, dice coefficient, true positive, true negative. These values are shown in the edit box. Now the estimation parameters are shown in the below. Thanks for watching this video.